Let's talk about the other limit definition of the derivative. So this will go specifically with section 211, which uses this definition for the derivative. So we're going to use this definition essentially anytime we're doing f prime of x instead of f prime of a particular number. So what'll come out as an answer is going to have an x in it. So it's like its own formula or its own function. This is just kind of a reimagining of the original definition with the f of x minus f of a over x minus a. And if we kind of view the same situation in this different way, it makes the limits ever so slightly more manageable. And this first example is a great example of that. So for this function, 2x squared plus 4x minus 9, we could absolutely compute f prime of x using the 2.10 definition with f of x and f of a, but we would have to do factor by grouping in the numerator to factor the top and cancel our numbers. If we do it this way, we can completely avoid the factor by grouping, which is nice. Okay, so we're going to use this definition for this first function. And I'll point out in this video, I have the same three types of examples as for the 2.10 video, the original limit definition of the derivative. So I have a polynomial where we'll factor and cancel. I have a root function where we'll do the conjugate trick, and I have a fraction where we'll do LCD. Okay, so for this first one, f prime of x will be the limit as h approaches 0 of f of x plus h minus f of x all over h. And just like before, I need to fill in the two pieces of this numerator. So f of x plus h is this function with x plus h plugged in. And then f of x is just this exact formula as is in a set of parentheses. All right, so f of x plus h, I'm going to take this spot and put parentheses x plus h, and this spot parentheses x plus h. So I have 2x plus h squared plus 4 times x plus h minus 9. All of that is f of x plus h. And then I want to subtract in parentheses just the original f of x formula, 2x squared plus 4x minus 9. And all of this is balancing on top of just that one little h. So I have a lot of expanding I need to do before I can factor and cancel anything. So that's going to be the focus of my next few steps, just to kind of clean up this numerator until it's manageable. The only thing I'm going to do in my next step is just FOIL out x plus h squared. So that's x plus h times x plus h. And when we do that, x plus h squared always comes out to x squared plus 2xh plus h squared. It's really important that we don't forget about this middle term that comes from the O and the I of FOIL, because if it's not there, it's going to slightly wreck every answer. Okay, so I have limit as h approaches 0, 2 on the outside, and now I'm going to put this expansion in for x plus h squared, x squared plus 2xh plus h squared. Everything else I'm going to leave the same for now. For h. Okay, so now I'm just going to do one step with a lot of distribution. So I'm going to distribute this 2 into its parentheses, this 4, and this subtraction here. And it's going to look really bad for a minute, but then that's when things will start to cancel and combine. So I have 2x squared plus 4xh plus 2h squared. And then when I distribute the 4, I get 4x and 4h. And then this minus sign distributing in is just going to flip the sign of all of these. So this will go to minus minus plus. Minus 2x squared minus 4x plus 9, all balancing on top of this little h. Okay, so now we're going to kind of go hunting through this numerator and cancel anything that cancels. So the first thing my eyes see is 2x squared minus 2x squared. I also see plus 4x minus 4x, and then minus 9 plus. And I'll do a quick check of what's left. 4xh, 2h squared, and 4h. None of those cancel each other. So that's going to be what's left of my numerator, which is much, much easier to deal with. And in fact, I'm going to kind of continue this up here for space. Each of those things left, these three terms, they all have an H in them. So I really like my goal here in the end is to plug in H equals 0, which I still can't, right? I can see the 0 over 0 limit happening. But what I can do is factor the H out of the numerator. This is where we're avoiding any sort of bad factoring and we're just pulling out an H. And I can cancel it with that denominator. So every term on top loses one of their H's. So now this can cancel with the bottom. And as soon as the H over H cancels, now I can just plug in 0 for H. And I want to be really careful because now I have two different letters in this limit and we're used to having only one. So we want to be careful here. The H is the thing that's going to 0. So this X stays X. We're only plugging in 0 for the H, which is right here. So that's 4x plus 2 times 0 plus 4, which simplifies to 4x plus 4. So this is the formula for the derivative of this function. The reason that this is helpful, and we kind of put up with all of these extra letters, is that now we can do f prime of any number for this function, and we never have to redo the limit. So if we want f prime of 0, just plug in 0 right here. If you want f prime of 10, just plug in 10 right here. And it gets us a lot more bang for our buck. All right, let's try the next function type, which is a root function. We're going to start off with the same limit definition, always h going to 0, f of x plus h minus f of x over h. And then for this function, I want to fill in the two pieces of the numerator. That's square root x plus h minus 1 minus square root x minus 1 all over h. And again, we might try to check, can I plug in h equals 0 right away? And you should find that you get 0 over 0, which is the exact same problem we had over here, right? And that should always be the case when we're doing these derivatives. You'll get a 0 over 0 limit. This one doesn't have polynomials to expand and factor. It has roots, so we'll do the conjugate trick here instead. And we're still just waiting for h over h to cancel so that we can plug in 0 for the h. All right, so the conjugate of the numerator, instead of root minus root, I want to do root plus root. So same roots, but with a plus sign between them. I want that to combine with the numerator so that I can get rid of the roots, but I have to also multiply it into this denominator to keep things balanced. All right, so on top, I have this root squared minus this root squared. So that's x plus h minus 1, kind of free of its root, minus x minus 1, also free of its root. So this is a squared minus b squared, all over the bad denominator that we have now created. All right, so I want to be very careful. These parentheses that I have on top, particularly these ones here, they're really important because I actually have another step I need to do, which is distribute that subtraction in there. And if I miss those parentheses, the sign of that last number is off and it kind of messes with my answer. All right, so that's all I'm going to do in this next step is just distribute that minus sign in. And now I should see convenient cancellation, kind of similar to what happened in this step above where everything canceled out. We have x minus x and minus 1 plus 1. So the only surviving term up here is h. And of course, that can cancel with the h that's in the denominator right now. We have a 1 left over on top. And as soon as that h over h cancels, we can just plug a 0 in for h. And remember, only the h is 0. The x's stay x's. So it's just this one little spot right here. So we could write this answer in a couple different ways. You could leave the denominator just root x minus 1 plus root x minus 1, or you could combine them to 2 root x minus 1. Either of those would be a perfectly good final answer. All right, let's do it one more time. Same definition, but this is the third and final option that we'll deal with. So same definition, but we're going to have fractions in the limit. So we'll have to do a least common denominator as our third option. So again, limit as h approaches 0, f of x plus h minus f of x all over h. All right, for this function, f of x plus h puts an x plus h right here. So that's 2 over x plus h plus 1. I'm subtracting just the regular f of x formula, which is 2 over x plus 1. And then it's all over h. So in this example and the one before it, I skipped the set of parentheses around f of x, right? So here the parentheses don't carry, and then same thing here, there's no parentheses. It's not wrong to write them in, but they're not needed here because this square root kind of automatically groups all this together anyway. And then because these are all tied up in a fraction, they're grouped together anyways. But the one that was a polynomial, we did really need to have that set of parentheses so that we could distribute the subtraction later. So for polynomials, those parentheses are really important. For other stuff, they might not be. All right, so again, 0 over 0, we see fractions, so we'll do a least common denominator. This numerator fraction minus fraction situation, each of them is going to get times top and bottom the other denominator. So this one gets x plus 1 top and bottom. This one gets x plus h plus 1 top and bottom. And it's going to get a little messy, but it'll work out just like the others. So this one gets times x plus 1. This one gets times x plus h plus 1. Okay, so that gives me 2 times x plus 1 minus 2 times x plus h plus 1 over the common denominator, which is this times this. And then this is all over h. And again, I like to avoid the triple-decker fraction. Divided by h is equivalent to times 1 over h. So I'm just going to keep it on the outside as its own thing. All right, and then I definitely have some cleanup I need to do. So I'm going to do a distribution step for the 2 and the negative 2. And then we should see terms cancel just like before. That gives me 2x plus 2 minus 2x minus 2h minus 2. Yeah, and now we see some nice cancellation. I see plus 2 minus 2, 2x minus 2x. So this minus 2h is the only thing that remains up there. And now I can see top and bottom, the h's cancel, which is the second to last step of all of these problems. So as soon as the h over h cancels, you're free to plug in 0. And again, it's only the h that turns into 0. So just right here. Like that. You could leave your denominator as x plus 1, or you could combine them into x plus 1 squared. And that's my answer for that derivative.